Hi, this is Tom Plummer, and what I want to demonstrate here are two new forms of the Faraday traditional homopolar motor. What I see on the web and on YouTube are the endless repetition of the same two forms, hundreds and hundreds of the same thing over and over again. They wear the battery out quickly, they're erratic, they're hard to demonstrate, they fall apart. Yes, you can make them in 1 minute, but I suggest you invest some more of your time and make some very good motors like the ones I'm going to demonstrate here. What you see going on here is the traditional Faraday motor. It looks like his original design from 1821 with a few exceptions. Down at the bottom, instead of a pool of mercury, you have a rolling contactor at the end of the wire, and this I call an outside hula hoop. But the point is it's rolling contact, which means it's very friction free. It is suspended on the point of a sheetrock screw up at the top with a magnet onto a it serves two things. It suspends it and makes it a low friction bearing, and it also allows the current to go through it. It's powered by a D cell and in line with a 1 ohm resistor. As you see this running, it has 11 hours of continuous operation to date. So I'll show you some of the parts. It just pulls off of the magnet. Here it is here. Okay, I'm going to show you the more traditional form of this, which you will recognize. It's got the penlight battery in the middle. In this case, I've built in some special resistor elements to it of 0.3 ohms, made out of 1 mil steel shim stock, and then I've made a rotator, an armature. I call anything that moves the armature. So when I put this on, I'm going to this is the inside hula hoop, and I'll demonstrate this. Again, only rolling contact, very friction-free point contact with current conduction up at the top, and at the bottom only rolling contact, which as it swings faster and faster, the contact gets harder and harder because of centrifugal force. So I have made these out of just house wiring. I had some heavy house wiring that I stripped the insulation off and then bent and formed the copper into the shapes I wanted. The embedded magnet at the bottom is it's a neodymium magnet. It is 5/8 of an inch in diameter by 3/8 of an inch long, and it fits perfectly into a little copper end cap for plumbing. I believe that's a 1/2 inch end cap, but it fits in perfectly, and it's interesting to watch it drop into the end cap. I have it soldered in place, but it's so strong that you immediately see forces, eddy current forces. It drops in and then it sort of slowly schmoozes to the bottom of the cap as though it's in molasses. But anyway, I wanted to demonstrate these two new forms because they solve various problems for me for the homopolar motor, and just wanted to introduce these. You can copy them yourself and actually have a nice motor to demonstrate instead of something that's been thrown together in 1 minute. That's about it. Adios. Have a nice day.